guys, today we will see how to control the speed of induction motors. So as we saw it inside the class, we saw that speed means 120 F over P. So from the equation we can see that in order to vary the synchronous speed of induction machine, we can vary by changing the frequency or by changing the pole. So this will be one of the speed control methods for induction motor. So the first one will be by changing the number of poles. So if we vary the pole, we can vary the speed of induction machine. And also if we vary the frequency, we can vary the speed of induction machine. And the other one is speed is directly proportional with the voltage. So if we vary the voltage, we can vary the speed of induction machine. So these three works for both in squirrel cage and phase wound induction machines. But when we see the advantage of phase wound over the squirrel cage one is we can change the speed torque characteristics by connecting the resistance to the rotor. But as we know in a squirrel cage, because of the squirrel cage's rotor are both sides short circuited, so there is no way to add additional resistance to the rotor. But because of we have a slip rings on phase wound induction machines, so we can add additional resistance. So by adding additional resistance to the rotor, we can vary the speed torque characteristics for phase wound induction machine. So here, as we saw, this one works only for phase wound, but these three works for both phase wound and squirrel cage one. So now let us start from the phase wound type. So let us connect a resistance to the rotor terminal and see how the speed varies. So here we will see that as the voltage increases from start, that means we connect the resistance in this way. We connect the whole resistance at starting, and then we slightly reduce the resistances until we reach to the rated speed of the machine. So now let us connect this thing or the resistance to the rotor terminal of the phase wound induction machine and see how can we vary the speed accordingly. So now here we have the parameters, so that let me connect the three phases, the first phase to the motor, and then the next phase, and then the third one. Now I'm going to give the full voltage. There is no variable voltage here. This supply 400 volt. Because of that, I will see the nameplate, and the nameplate says that when it's connected in a star, we should have to give 400 voltage. So 400 voltage will be given to the motor when I connect them in a star. So I will use a small one to show how to connect them in a star. So I will start them. I will start the second terminal. So if it's connected in a star, I can give a full voltage to the motor. But if it is connected in delta, it says you should have to give like 230. So there must be a variable transformer so that we can minimize the phase voltage to 230. But now we have 400 volts, then we can directly give 400 volts to the motor by connecting them in a star. So I am connecting the three resistances to the KLM value. So the first resistance value, and then the second, and then the third. So those three goes to KLM. That means the rotor resistance to the slip ring. So I connect the resistances to the slip rings, then I will show this one. So as I said before, the advantage of phase wound over the squirrel cage one is we can add additional resistance to the slip ring. So I connect additional resistance to the slip rings, then I will make the resistance to the 100%, then I will start the motor. Now the motor starts. Then I will see the speed measure. So as you see it here, we will wait a bit to see the difference. So here at 100%, and at 100%, the speed is around 798.3 revolution per minute. Now I will decrease the resistance value to 80%. Then I will see the speed. Be careful with this one. So as you see, the speed increases. Like now it's like 871.2 revolution per minute. Then I will also slightly decrease the resistance. Let us make it to 50. You can also check the speed by hearing the sound. So there is a difference in sound when the speed increases. So here, as you see, it's 1026.3. Now let us also decrease the resistance value to 20. You can hear the sound. Then I will measure the speed with the tachometer. Now the speed is 1221.5 revolution per minute. Now I will decrease the resistance value to 5%. So you can see that the speed is 1367.5. Now I will make, now all the resistance are disconnected from the motor. Then I will expect the rated speed from the machine. So I will let me make it there. So now the rated speed is 1447.1. So in this way we can vary the speed of induction machine. So this works only for squirrel cage one. So next time we will see how to vary the speed of induction machine by varying the input voltage. Then till then, see you.